Today we are going to start Introduction to Proof. And if you see in the first slide, it says if you were 3 feet tall at age 2, then your adult height will be about 6 feet tall. Prove it. Proof is all about writing justifications, making an argument. People don't just believe you because you say so, you've got to back it up. So we're going to start learning proof by relying on something you already know how to do, which is algebra. We turn to the next slide. Okay, what is proof? It's a method for making an argument. Statements are made and justifications are given. There are two styles of geometric proof. First style is a 2-column format where you've got a column for your statements and then you have a column for the matching reasons that back them up. The second style, which is the more realistic real-world style, paragraph proof, statements and reasons are written in sentence format. We're going to focus on 2-column format simply because starting off it's going to give you a good structure and a good outline for keeping you organized as you start to learn this. When we start our proof, we start out with our first column, making our columns, and we're going to put our headings. On the left column, we're going to title those statements. The right-hand column will be our reasons. When we start proof, we always have to be given some information, and you always have to be told what it is you're trying to prove. What you are trying to prove is going to be your very last step. It's the goal to which you're working toward. I will never give you anything that doesn't work. So if you follow the steps of a proof, and let's say, here we want to prove a equals 3, and you get a equals 7. Either one of two things happen. Either I made a mistake, and I have a typo, or you made a math error. So the first thing you should do is go back and recheck your calculations to make sure that it matches. So when we start this, our first step will always come from our given information. So we're going to start our first statement, 5 quantity 3a minus 7 equals 10. And the reason, where did it come from? It was given to us. Notice that we are numbering the statements and the reasons as we go. So if it takes more than one line to write something, everything's organized and we know what matches with what. When we solve this equation, the first thing you have to remember is order of operations, which say parentheses first. So we're going to knock out the parentheses. 5 times 3a is 15a. 5 times negative 7 is a negative 35. And the reason, if you can think of the property from algebra, when we multiply all the terms inside parentheses by a number outside, that is use of the distributive property. Next, if we're solving this equation, you would ask yourself, what do you have to do to get the a term by itself? Well, I have to move this minus 35. When we move a term, we perform the opposite operation. So the opposite of subtracting 35 would be adding 35. Now, notice I'm not going to put plus 35 to both sides in my proof. What a proof does is shows you what happens after you perform the operation. If you just want to tack it underneath so that you have it for your own work, that you could do that as well. So if I add 35 to both sides in step 3, I'm left with 15a is equal to 45. What did I do to both sides? I added 35 to both sides. So this is the addition property. Now, what do you do to both sides to get the a by itself? You would divide both sides by 15, and you would be left with a equals 3, which, as you know, that is what we were trying to prove. Since we divided both sides by 15, our reason is the division property. In our next example, again, we're going to start out writing our headings. Statements, and reasons. Step 1 always comes from our given information. And the reason is it is given to us. Once again, order of operations, we need to get rid of parentheses first. So we are going to multiply every term inside parentheses by a -3. -3 times n is -3n. -3 times +6 is -18. And this again was the distributor property. Now, before we go on any further, we notice that we have some like terms, 2n and 3n. So we're going to combine some like terms. 2n minus 3n is -1n. When we combine like terms, we're taking one representation, 2n minus 3n, and replacing it with an equivalent form, -1n. Kind of like what happens when I'm not here. I am replaced, and we call my replacement a substitute. So we call this type of replacement the substitution property. Do not abbreviate substitution property with SUB, as that could be misinterpreted for subtraction. Please write it out. Now, continuing on, to get the variable by itself, we would add 18 to both sides, in which case we're left with -1n is equal to 23. Since we added 18 to both sides, the addition property, now if you notice, we have -1n equals 23, but we want to prove that n is equal to -23. And we're solving for a positive n. So now we divide both sides by -1. So we have n equals -23. Since we're dividing both sides by -1, it is the division property.